All right, 15.8, vectors. More vectors. Resolution into components. And so when you see the directions to resolve a vector, all that means is to break it up into components. And what the heck does that mean? Well, a vector can be defined by writing it as 4i plus 3j, where I represents the horizontal direction or the x direction. It's the horizontal displacement of the vector. And then the j component is the y direction or the vertical displacement. All right, so what does that mean? Well, if I were to draw this vector, then 4i plus 3j just means, if here's my x, y plane, right? 4 in the x direction, 1, 2, 3, 4. Yeah. 3 in the y direction, 1, 2, 3. And that means it would have went 4 to the right, up 3, and it would have stopped there, starting at the origin and going and stopping at there. Yeah, that's what that means. Where if you could, drop the perpendicular down, and this is 3 units, and then this is 4 units. Yeah, that's all that is. Another way to write this vector, any vector, is by taking its magnitude, because sometimes they'll just give you the magnitude. So taking its magnitude times the cosine of, they might give you a direction angle. Well, they would have to for this, right? So if they give you, so let's define this. This means the magnitude and theta is the direction angle. So if instead of them giving you that, oh, vector b is 4i plus 3j, if instead they say, oh, this vector has a magnitude of 5 with a direction angle of 30 degrees or something like that, then you can still get, you can turn this information into this guy by taking the magnitude times the cosine of theta times vector I plus the magnitude times the sine of theta times vector j. Oh, all right, so let's do an example. They tell us to resolve the vector into its horizontal and vertical components. I barely squeeze that in, not really. All right, where they give us that the magnitude of the vector is 3 and the direction angle is 143 degrees. All right, so they gave us the magnitude, they give us the direction angle, and they want us to resolve the vector into its horizontal and vertical components. So they want us to turn it into this IJ notation like that. So, side note, where is this stuff coming from? Do you remember that cosine of theta is x over r? Yeah. Well, if you just multiply both sides by r, then that means r times cosine of theta is equal to x. R is going to be that magnitude and then cosine of theta. So this is your x part and then times I. And then if you remember that sine of theta is y over r, and by multiplying both sides by r, that means y is equal to r times sine of theta. Y is equal to r sine of theta x. So that's where your r is that distance from the origin to the end of your thing. So this is r, or the magnitude of your vector. So that's where those are coming from. Okay, so what do I have? Magnitude, that means this is absolute value of my vector v. Direction angle is the theta when I was talking about these guys. And so let's find the x part first. X is going to equal the magnitude times the cosine of theta. So 3 times cosine of 143 degrees. And put that in your calculator since it's not one we've got memorized, right? 3 times cosine of 143 degrees. That's going to give you about negative 2.395. Let's go 3959, blah, blah, blah. We'll probably go to 3 decimal places, I guess. Y is equal to 3 times sine of 143 degrees. So 3 times sine of 143 gives me about 1.8054. So let's go to 3 decimal places. Sounds good. So your vector v, your vector in its horizontal and vertical components is going to be negative 2.9. I did not write that right. All right, I missed it. I missed a point. I missed 3 times cosine of 143. 2.3. I missed a number there. 2.3959. There we go. Okay, so 2. Gotta get my white out. Oh, okay. 2.39. If I'm going into 3 decimal places, I would go 6 times vector I. Vector I is just the horizontal unit vector. And then plus 1.805 times vector j. There you go. That's breaking it into its horizontal and vertical components, writing it in terms of i's and j's like that. All right, let's do another example. Again, resolve into horizontal and vertical components. This time, though, it'll be that the magnitude is 30 and the direction angle is 200 degrees. So you just go x is equal to 30 times cosine of 200 degrees. We'll put that in our calculator. 30 times cosine of 200, and I get, what is that, negative 28.191, negative 28.1907, and then y is going to be 30 times sine of 200 degrees. There we go. I got negative 10.26, negative 10.2606, boop, boop, boop. And so, putting these into their horizontal and vertical components, you would get negative 28.191 times I plus a negative, so I'm just going to go minus 10.261 times vector j. There we go. All right, are you ready to try one on your own? Do it, right? I want you to, same directions, resolve into the vertical components if the magnitude is 8 and the direction angle is 310 degrees. Try it on your own, pause the video right now, and then come do it, see if you got it right, come back and check. All right, hopefully you have paused the video, done it, and let's see what we got. Your x is going to be 8 times cosine of 310 degrees, 5.1423. y will be 8 times sine of 310 degrees. Is today's lesson the easiest ever or what? Gotta love it, yes. I got a negative 6.1283, blah, blah, blah. And so their horizontal component would be 5.142 times vector I, and then plus a negative, so I'll just write minus 6.128 times vector J. And there you go. Easy peasy lemon squeezy, right? Love it. All right, I hope you all are having a fabulous day. Bye.